This lesson has been developed in the framework of SCILED project. Module 3, Footwear Design Engineering. Unit 1, CAD/CAM CAE Systems for supporting integrated footwear design.
Lesson 1.3. Overview on CAD/CAM CAE systems for the footwear industry.
Current computer-aided modeling practices in the footwear industry. CAD systems and software. Computational tools to determine footwear performance.
Current computer-aided modeling practices in footwear industry.
The use of 3D modeling software has been included in the design cycle, also in the footwear field, since the origin of the software itself. This is due to the several advantages that their use brings. The most important advantages are related to cost and time savings. Thanks to the use of CAD/CAM CAE software, it is possible to carry out initial tests even without the creation of a physical model that could later turn out to be ergonomically incorrect. In addition, the ability to quickly and accurately visualize the footwear leads to a reduction in both mock-ups and production times. These software also expand the design possibilities both by giving strength to the creativity of designers and giving them the possibility to create high-performance footwear. From the previous pages, it is possible to see how CAD/CAM CAE software comes into play, according to the needs, at different moments of the design cycle. Footwear, like other products, follows traditional steps. When the information has been received from the commercial departments and the brief has been formulated, it is possible to begin the design by carrying out further research and formulating one or more concepts that can be communicated through sketches. Once the most promising concept has been selected, it is possible to proceed with product development. During this phase, the first 3D models emerge. Alongside the development of the concept, if necessary, the last is also developed. Define the footwear. It is possible to proceed with tests. These can be carried out both physically and digitally using CAE software in the 3D model. Once the tests have been completed and the product validated, production can be prepared with CAM, nesting, and other software.
CAD systems and software.
To simplify the analysis of the most common and important software used in the world of footwear design, these will be analyzed following the different design phases. The first one is the realization of a concept through graphic artifacts and sketches. The Adobe suite, in particular Adobe Illustrator and Adobe Photoshop, is the most widespread, thanks to its simplicity and completeness. Moreover, these programs offer a wide range of uses that go far beyond the simple sketching, becoming useful also in other contexts and for different uses. Finally, these can be used with tools as graphics tablets to simplify the experience and make it easier. Once the concept is defined, it is possible to continue with the modeling, first of all of the last if it is necessary, and then of the footwear. For this purpose in the scientific literature, one of the most popular software is certainly PowerShape, from Autodesk. The latter allows the realization of complex 3D models keeping a very high standard of precision, able to transfer their data to CAM CAE software without any problem, such as PowerMill. This is possible thanks to a series of tools and functions added over time to the software and capable of checking geometries and highlighting errors. For commercial use, there are other software, such as Rhinoceros and Kacha. These are very common but less specific to footwear products.
Rhinoceros is also used for the design of very different products, such as boats, cars, and architecture. This shows its flexibility and usability, elements that have made it so famous.
In addition, thanks to a large number of plugins and online resources, it is possible to quickly learn how to use it and achieve excellent results. Kacha, on the other hand, proves to be more precise than the previous software. It also provides a series of functions, capable of assembling different parts and carrying out the first analysis of the assembly model. Kacha also allows the sharing and editing of files with different participants, through an online portal. Once the three-dimensional model has been developed, it can be used in many ways. One of the most common and widespread is certainly the photorealistic visualization of the product, both for internal use and for further development, but also its communication to the public and customers. In this case, for the commercial use, software such as Keyshot and V-Ray are the most widespread. Both allow instant viewing of the model and maximum customization of materials and textures. Another use, increasingly widespread also in the world of footwear, is the rapid prototyping through 3D printers. The improvement in quality and the reduction in costs of this technology meant that it was also used daily by a footwear designer. Companies that in recent years have introduced 3D printers into their offices, often properly hacked, have started to use them to prototype footwear or parts of them. To allow the use of the three-dimensional model to the device, so-called slicing software are required.
The most common are certainly Cura and Slicer.
The uses and possibilities of a 2D/3D model are endless. For this reason, in the world of footwear, suites are often used. That includes different programs capable of covering most of the needs within a design cycle. For example, to simplify and optimize the sustainability and consumption of leather cutting, nesting programs using blueprints of the upper are often used. These programs are very different and often depend on the country. In Spain, for example, one of the most popular suites is the iCAD series, from
Iniscap. In Portugal, the Mine series is very widespread, and in Italy, it's possible to find the software offered by Teseo.
The programs within the various packages are perfectly compatible with each other and guide the designer from the early concept stages to the most advanced engineering and visualization phases. Each software has a specific function dedicated often to specific footwear components. In addition, 3D scanning and nesting programs are often delivered with high-precision hardware directly connected to the software. The iCAD 3D Plus suite from Iniscap can be used in combination with many other tools to obtain digital materials and online tools for decision-making and product customization throughout the whole design process.
Computational tool to determine footwear performance.
Footwear is a complex element in which every aspect is connected to the other, so there is no universally adopted method to determine perfect performance. These often vary from each company. However, some aspects and practices are more widespread than others thanks to some hardware and software. These can be used in the early stages of analysis by collecting data using high-speed cameras or force platforms, such as podiums. In the first case it is possible to analyze the movements that the person and the shoe make, with extreme precision, and also reproduce them virtually using software such as Motion Builder, MOBU. The platforms are often accompanied by proprietary software that allows them to obtain graphs with useful numbers to be inserted in subsequent software. Once the concept and the three-dimensional model has been realized, it is possible to continue with the testing phase on the new footwear. This can be addressed virtually by reducing time and costs. Performing virtual simulations also allows to make fast changes to the footwear to get closer to the perfect result. Such simulations are possible thanks to CAE software, which bases its calculations on mathematical models such as the finite element analysis, FEM, method that we will discuss in another later. To proceed with the analysis, both a virtual anatomical model of a foot and a shoe model are required. In this field, the most popular software are Explicit Dynamic STR and ABAC. The first is a CAE software able to simulate the response of different structures to different loads that these can undergo, even of particularly complex objects and elements. The program makes it possible to set up different forces during the simulation period, even of a very short duration, thus predicting the deformation of the inserted materials and their collapse. ABAC by default system, instead, can analyze multiple bodies considering a load over the objects, but also the dynamic vibrations, reactions and joints between components even in motion. In addition, the analyses that can be carried out do not only concern structural loads, but can also take into account thermal aspects, impacts, and collisions.